So with that, I'm very proud to be able to introduce Brandon Russell. So Brandon is on my team at EBSCO. From 1998 to 2002, he was lead developer and co-creator of Day of Defeat, a fantastic World War II shooter that was later acquired by Valve Software, and he used to go work for Valve. I'm sure several people here may have heard of them. In 2003 to 2008, he was a sequel developer for Mellior. He then went to from 2008 to 2015. He was a senior developer at ProAssurance. I think we got some ProAssurance guys here tonight. And then from 2015 to present, he has been on my team at EBSCO and has very quickly become one of my most trusted associates. It's somebody that I can go to with technical things, and I just consider him a close friend. And the thing he's going to be talking about tonight, performance tooling in VS 2015, this came out of an issue we were dealing with at EBSCO where we literally had all hands on deck. Brandon was the one that got in there, figured all this stuff out, and at the end of it, we're like, we got to show this to somebody. We can't just keep this information to ourselves. So with that, Brandon Russell.
All right, let me get set up here just a second. Swap over. All right, well, good evening, everybody. Like I said, Blake introduced this talk. Actually, I had another talk I was going to give first here, but this one came of such importance for the issues that we found at EBSCO. It was like, we got to show this. We got to get this word out on how to do this. I won't skip the intro because he's already done that. To lay the groundwork on this, I'm going to go into build a little foundation first on how memory and things work behind the scenes. I'm not going to get into details of how .NET does things, but I'm going to bring it with a little how we used to do it in C and C++, coming from a real-time application, a video game background, some pretty neat things that are going down in the core. So when I start explaining how these tools work and I start pointing things out, you'll get a little better understanding of what I'm talking about when I'm talking about the garbage collector and when it fires and how to get around things like that. So some of the topics I'll go over real quick, and like I said, this is real brief. I just want to make a good foundation. We'll talk quickly about the difference. Why is the difference between debug and release mode? Why is my memory footprint between the two different, and why is performance difference in between them? And what is the garbage collector, and how does that fire? When does it fire? Things like that. So in .NET, we have a lot of things that's taken care of it for us behind the scenes that we don't have to worry about, and that's great. I'm telling you, coming from a C++ background, when we had to do these real-time applications, you had to roll your own, or you had to go buy somebody else's work that's already done it. One important thing is like with the garbage collector, for instance. You either had to write your own memory management system, or you just had to do the best you could. But basically, what you did in a real-time application, one of the main things, the most performant hits that you can, well, there we go. I'll grab that later. Yeah. One of the most performant things you can do is newing up and releasing, allocating or deallocating memory. So what you generally do in a real-time application, let's say you have an application you know you're going to be running in about the 2-3 gig range. What you're going to do up front in your memory allocation, you're going to grab all that memory up front. You're going to overload your news and your deletes, your mallocs, all that good stuff. Behind the scenes, whenever that's being called in your app, it's being wired behind the scene to the memory manager. And what that's doing is just basically saying, say I've got a texture I want to load. It's 250K. I need 250K of memory. So the memory allocator looks in the free pool that it has, gives that memory to it, allocates to it. Now, what happens in debug and release mode is, so if you ever want to track where your memory problems are, you want to know where something got allocated, you want to know what line number, file number, what was the name of it, and maybe you want to store a bit mask of it of, was this a texture, basically a flag. Was this a texture, was this sound, was this level data? What was this that allocated this memory? So when you do a memory dump, you can go back and analyze it. We could also have tools, we could watch memory allocation on the fly. You ever seen it? You remember the old defrag screens? Remember the big old grid? I'm probably showing my age now, but basically we had an app that did that. It looked just like a defrag machine, but I could tell by color coding what was being allocated. Was it, here's my textures, here's my sound, and basically it was my memory getting fragmented. Now, the reason why debug and release mode is a little different, and this is what Microsoft does behind the scenes in your garbage collection. Say I need to allocate that 250K of memory. Well, what it's going to do is it's going to envelope it. It's going to wrap it around with that little extra, basically picture a header or a footer. It's going to put around that 250K. And that tells the information about where was I allocated, what file, the file number location, and any other kind of information they want to track along with it. So that 250K gets bloated just a little bit in size. So that's why when in .NET, if you're ever watching your task manager or monitoring memory like that, you may see if I'm running in debug mode, I've noticed my memory is pretty high. But when I push it out release mode, get it out on the server, I notice my footprint's a lot smaller. That's your difference there. That's because Microsoft is actually giving you extra footprints to track along with that data. Now, so what the garbage collector does for us is basically that memory management I was telling you about earlier. That is running behind the scenes in .NET. And so it's basically putting a big umbrella around your app. And so it's giving you the freedom of having your memory allocated for you. You don't have to worry about freeing and deleting, and if my app closes, did I just make a memory leak? Did it go back to the system or not? That garbage collector is going to take care of that for you. It's also not really made for a performing app. It's not got real-time applications in mind. It's made more for business apps. But what it tries to do behind the scenes is it'll either fire on timing or it'll fire off events. And so what it does is it goes back to the pool that you have in your app. Say I've already run it at 500 megs. It goes through the object tree and basically has what's called smart pointers. If you've ever in C, C++, you may have played with the Boost library. There's things called smart pointers there. Basically what it is whenever I make a pointer of a memory allocation, it's keeping a counter, a reference counter behind the scenes of every time somebody takes reference of my object. And every time you deallocate or null up that reference, it minimizes, it decrements the counter for you. So what it does is it looks at all the memory allocation, the tree of it, and it's saying, okay, is there any in here that are not taking reference on anything? Am I zeroed out on my reference counters? If so, those are my free memory. I'm gonna grab that memory they were using at one time. And so your memory stays in the chunk. Now, let's say you didn't have, and I know this is a big overload, I'm trying to build a little foundation for you. Let's say you have a 500 megs and nothing is freed. Well, what it does is it goes ahead, grabs another chunk of memory that it needs, and now it's holding on to that. And so what happens behind the scenes if you have a memory leak, which in .NET terms you can't really have a true, in a sense, memory leak. But what's really happening behind the scenes is sometimes we don't properly deallocate or dereference our variables. Say you have a disposable app or a disposable object. Sometimes we don't properly run the disposable pattern on it. Don't clean up behind ourselves. Actually, I'm going to go, some of the common mistakes we have is sometimes we leave connections hanging. I'm the world's worst at that. I actually did that today. I found one I had. And that's connections, WCF connections, SQL connections, anything like that that's hanging around, lingering behind the scenes. Next is, like I was mentioning, holding those references to managed objects. And that's basically, we're just not cleaning up properly behind ourselves. So everything in memory, even though we're done with that object, it may have had references to other class objects that we created, but we didn't properly clean up or release those references. So when the garbage collector comes around to free up that memory, it sees that object and it says, oh, it's still got allocations on these objects. I can't clean it. I'm going to have to go to next. And it keeps going, and if it can't find anything, grabs another chunk of memory, puts it in the pool. So what that looks like is, if you're not we'll go over these tools that are in Studio 2015 that you can watch it. But what you're going to see in your task manager or anything like that is you're just going to see your memory just growing and growing and growing until eventually your system runs out of memory. And it can happen because we've proven it can happen. The other thing is if you ever use unmanaged resources, things like p-invokes outside of the .NET world, now you're getting back into Win32 stuff. You gotta play by their rules. If you use DCs like get DC, you gotta release DC. Working with COM objects, things like that, you gotta play with their rules. If you allocate it, you gotta properly deallocate it. That one's not so bad. We're not usually playing with a lot of unmanaged resources, but it can happen. I mean, there's instances where you do have to use it. So I know that was a really rough, quick overview of how memory works, but what I'm going to get into now is actually talking about the tools that are now in 2015. And if you haven't tried 2015 yet, it's a great time to get in it because they just released update 3, fixed a lot of memory usage allocations on it of itself. But they introduced these tools in 2013, but they really wasn't mature enough yet. You really couldn't take full advantage of like what I'm going to demonstrate tonight. So 2015, they really stepped their game up. And if you've ever fired up debug mode in 2015, this is probably the first window you've come to. And if you was like me, it was probably the first window you unpinned or closed to get out of the way. I was like, oh, that's pretty. Got some graphs and things. All right, get out of my way. So, but I want to actually show you how, in concert with one another, each of the sections, how you can really bring it to your full usage. So some of the new additions that they added from 2013 is they give us perf tips on break events. This one gives you a little bit of a lapse timer on how long it took the code to get between the breakpoints. It's a good. I wouldn't take this to the bank on how fast your code is actually running, but it's a good measurement of I know something's taking a long time. Is this a problem area? It's a good litmus test. Next thing is the CPU and the memory analysis pane. This right here, visually, it's going to tell a lot of things going on. And once you play with it more, you'll find out how to really read it. I know that's a bad screenshot, but there's actually a legend here. There's little events. Every time you see a yellow hit, that's actually going to be that garbage collector I was telling you about, the GC, the garbage collector firing. And then whenever you take a snapshot, it'll give you a nice little peg on there knowing where you took a memory snapshot. Also on here, it'll actually show you there's little diamonds. Every time there's a diamond fire, and that's an IntelliSense hit, you can hover over that. It'll give you a little information of what fired there. Of course, the red ones are any exceptions being thrown. So it's a good measure, and we'll demonstrate in a minute of how to stress test an app on even a function of a service and watch what's happening behind the scenes to try to troubleshoot what's going on. The next part is they added in the actual IntelliTrace performance insights. This works great if you work with Entity Framework or making SQL calls, especially because this actually puts up the actual SQL statement that was ran. So you can actually look at it and see what's going on behind the scenes. Any kind of exception messages, things like that will be thrown there. It's really neat because double click, jump right into where on the call stack, see everything that happened. The next part, this is where it really comes into play here. So just on the other tab, the memory usage is where you can actually take snapshots, and this is where it really comes in, really comes to the light here, because what you can do is you can stress test your application, and once you can get a replication of a problem happening, you can take you a snapshot, go run it again, and I'm going to demonstrate that in just a moment. That you can take a snapshot, hit it again, hit it with some more concurrent users, and one of the main things that we discovered is, especially when you have these memory leaks or possible in your application, they can be sitting out there dormant for years. You won't even see it. In our case, there was one that was been out there since 2014, never seen it. What brought it to light was a combination of adding some more services to the box and then taking on more concurrent users, opening it up to more departments, letting more people hit it. Once you really got that concurrent user base hitting it at the same time, that's where you really start seeing that memory usage spike. And it was enough to actually bring the box down to its knees, which affects everything on the box. So what we're going to do is we're actually going to demonstrate putting the app under load and taking some snapshots in between, and it's going to basically show you, am I deallocating or am I still allocating, and that just those objects staying in memory behind the scenes. And in between each one, you can actually click on it and get to a list view and see what is actually behind the scenes between the snapshot. It'll actually give you the objects in memory. So it's pretty powerful stuff. So I'm going to jump right into the demo here. And what I have, let me get my screen set up. So what I have here, oh, is it running? There it goes, okay. So right here I have a basic WCF service. Running behind the scenes, it's got a data access class. I mean, it's really behind the scene. It's just loading some data from the VentureWorks database, just something really simple. Let's see if I can get that zoomed in a little bit. See a little better. Is that a little better? Okay. So all this code, by the way, I have up on GitHub, so I'll give that link at the end. But if anything out of this, of course, this is a good litmus test to take back and play with, because it demonstrates just a common problem. But the test client that's in here is basically going to mimic hitting the service with multiple concurrent users, and you can put in how many concurrent users you'd like to stress test it with. So, and that's what's going to really bring the problem to the front a lot quicker, so you can see what's going on. So I'm going to fire this up on the WCF service. And so when you first get in, the very first thing I like to do is I go ahead and take a snapshot as my baseline. So that's giving me an idea of everything jitted up in memory right now. And you can see right here, this little blue icon, that's my snapshot. That's where I took it in time. So now I already have the app running back here. I'm going to simulate, let's say I'm going to simulate with 5 users, concurrent users. So I'm going to go ahead and hit that. I want you to watch the graph going on behind the scenes here. So she's growing in memory. You can actually see the garbage collector fire off. It fires off again. Memory hits up, peaks, plateaus off. So we're back. All 5 calls are done. Now, so the memory has stayed high, which is fine for the first hit. I'm going to go ahead and take a snapshot. So you can see exactly how many objects and the heap size, everything that's captured right there in this snapshot. Now, I want to go ahead, I want to hit it with 5 more users. And you're actually going to see the graph again start taking off. So at this point, you know, the garbage collector is fired again. My memory has not come down. I'm not seeing any deallocation. It's staying high. It's actually climbed. So I'm actually going to take another snapshot in memory. And as you can see, between snapshots of the first one, I'm already up 113,000 objects. So nothing has freed, nothing has come down. My memory has only gone up. Actually, if I bring up Task Manager, I can bring this up where you can see it as well in Task Manager. We'll go ahead and I'm going to fire it again with 5 more and just see, watching the memory climb. Now at this point, I'm noticing memory ain't coming down, it's continuing to climb, and it's just continuing to grow. And I'm only hitting it with 5 concurrent users right now. Take another snapshot, memory's not coming down at all. I'm just going to go ahead and I'm going to hit it with about 20 users. Now you can, when you really discover a problem, one, you're going to see it over here in your performance tools. But I can tell you from experience, you can keep pounding this thing and eventually you're going to bring your system to its knees. And actually the snapshot tool is pretty funny. It'll actually tell you that behind the scenes that it can't even take a snapshot anymore. There's too many objects in memory for it to track. And like I said, this is, as you can see, we're already up to almost 700 megs. And so it's still climbing. This right here is, if you have a problem in production and you have a lot of users hitting it, you're going to see this kind of a problem pretty fast. I mean, it's just going to happen. But if you have something that's running on a box, there's not a lot of concurrent users hitting it, or maybe other services are hitting it, it's a good chance that you may fall into the fact that we had, where we just didn't find these problems till months or years later, because it was just enough that it would get up in memory, because they're hosted in, our WCF services are hosted in IIS, for instance. So they'd get up in memory, they'd hold, and then at the end of the business day, it wasn't enough to trigger any alarms or bring the box down. But by the end of the business day, people quit hitting it, the app poo would go out of memory, recycle, and it would be reset. Next business day, everything's good, you're back at the bottom. So what really triggers a lot of these events is taking on more concurrent users or adding more apps to your box. That's enough to eat that memory up to bring the box to its knees. So at this point, I'm just going to take one last snapshot. At this point, I mean, we can demonstrate that our memory, it continues to climb. Every snapshot I take, it's not freeing, it's only staying up. It's growing in object size, it's growing in actual heap size between them. So the problem that we had, and I'll briefly go into a quick how this whole thing come about, was we basically had a situation where one day we're in the middle of a sprint working, and ALM comes to us and says, hey, production box is brought down to its knees. We're looking at the task monitor and it looks like one of y'all's apps is high up on the list. So we go over, take a look, and we notice, okay, there's quite a few, about 2 or 3 apps that's really taking up a lot of memory. So at that point, you know, we've never had any problems, didn't have any releases lately. Went ahead and recycled the app poo, let it go, watched it, go back, whatever. Wasn't getting any errors, anything like that. Then it just kept escalating. Come back again. Hey, the box it's locked up again. Now we got load balances, so there's multiple boxes. So it's not just one box, there's multiple boxes. But even under load balances, each one of the boxes are starting to get brought down to their knees. So then that's when we realized, okay, we got an issue. We even had problems where TCP ports was running out of socket requests. It was really a, all hands on deck. What do you do? We had a lot of our senior people out of pocket. They were gone to one of our northern offices for a meeting. So it was really all right, let's get together, let's see what we can figure out, And so what some of us did was took a look at what was our biggest offending apps. Let's start there. So we found, we identified out of the top 3, we identified one that was really bad. So, okay, let's take that one. Let's see if we can replicate it, get it downloaded. So we brought it down to our box. Never seen this code before, and don't know how it works. Luckily got it working, but out of the functions on it, luckily this one was a small one. There was really only a couple functions that you actually call, that our apps called. So okay, let's demonstrate if we can call that function. Let's see if we can replicate what's going on. So wrote a little console app, put concurrent users hitting it at the same time. And once we started calling it with the multiple concurrent users, like I showed you here, that's when we started realizing, hey, this memory is going through the roof. Luckily, we had played with this a little while back and found a way to play with the memory snapshots. Thought it was a really neat idea, but never really put it to practical use. But we tried it there, and so what we was able to see was what I'm about to show you here is when you break down into the actual snapshots, now you can get an actual graph of what's going on behind the scenes. Now, you can compare it to your baseline, or I can just go straight up and compare it to a previous snapshot. So I can sort by the count differences. And as I play with this, you can start seeing some offenders rise to the top that sort of gives you an idea of what's going on. Now, in this case, this one is going to be some basic .NET stuff, but don't be surprised if you see a lot of signs over here that just really stand out of your own class objects. So we're seeing a lot of SQL metadata, SQL connections, things like that. We sort by the inclusive difference size, and I can tell you right now by experience, by Googling this, these right here have to deal with SQL connections behind the scene. So this is actually part of the SQL connection class. So SQL metadata, internal connections, these things are rising to the top. So this is giving me an idea of where I need to go to start looking. Before this utility come out, it's anybody's guess. I don't know if we could have found the problems as quick as we did. We literally turned it around in a day time by doing this. So if I sort this by the sizes and things, I can see that this is dealing with SQL connections. So this gives me an idea of where to start. So I'm going to demonstrate now by closing this. And you would have thought I pre-made this talk or something. I actually have a little cleanup section here. I'm looking at my connection strings and where I knew up the connections. I'm noticing something that sticks out pretty clear, that I'm not closing these connections. I'm not disposing them. So I look down in here and I actually have the code commented out for this demonstration. Here's where my problem is. I've not closed them, not disposed them, not cleaned up behind myself. So I'm just going to uncomment this and try this up again and see where we lay. So I'm going to fire it back up. And I've got my startup over here. I'm going to take a snapshot from my baseline. Now I'm going to fire it up with, we'll start off with 5 users and see. So it's going to grow up in memory. That's it running everything for the first time, allocating that memory, growing the pool up. You can see the garbage collector firing off. I'm going to take a snapshot. Now I expect there to be objects in this snapshot because this is the first time we've actually hit it up and ran. I'll call it with 5 more. You can see the garbage collector firing. I'm not actually seeing that climb anymore. You notice that. Staying pretty solid. I'm done. I actually dropped down a little. Take a look at the actual sizes reported here. I'm going to take a snapshot. Wow, look at that. Already. Deallocations. Objects have gone down. That's what I want to see. All right. I'm going to fire it up with 20 users. So even with it hitting with 20 users right now, I'm actually seeing, I don't know if you can see that, I can actually see a dip in it by increasing the user count and the garbage collector firing. That's a healthy app. That's what you want to see. I want to let this finish and then I'll take a snapshot. But this right here is just demonstrating just something that's built in the studio. All you need to be able to do is replicate hitting the problem, hitting the service, and using this tool to your advantage. Take a snapshot. I've actually dropped in memory there. Now, there's times where it's going to show you that you've gone up. That's fine. That's just it not catching up with a garbage collector. I take another snapshot. You can see now how it's reflecting. That's what I want to see. That's a fix right there. All right, I'm going to stop that where I'm at, and I'm going to jump back over here. All right. So this is a graph of a logic monitor that we use to monitor our processes and our memory allocations. This was the first app that we came across that really brought this whole issue to a head. This had been running for a long time and running fine, no signs of problems. This was during the heated part of when we were really trying to figure out what was going on. I don't know if you can see that, but that's actually about 3 gigs in memory there. What this graph isn't representing is there's other apps on the box with it. What was happening was this was actually continuing to rise. What you see cut off here was where we went into panic mode and recycle the app pool, or if in drastic cases having to reboot the box. So that's where you see the dramatic fall off. This was a constant thing, and what ended up happening was we actually found out we took on 20 extra users to one application that was on the box. That application ultimately used this service that was running behind the scenes. This service hadn't been changed. We didn't think in itself it was a problem because it hadn't been touched. But it was the fact that another service that relied on it took on 20 other users, brought this one up to a head. After using the same demonstration I just showed you of how we went into it and found the problem, it was literally a simple fix, much simpler than the one I showed you. This is what it looks like now. Even if you go look at it today, it doesn't top 300 megs. That right there is just, this was replicated again. We was like, okay, so this was a great little idea. Let's see if we can try this for the second offending app. We pulled in the second one, looked at it. It was doing the same thing as this one. Simple fix. It was not doing an eye-disposable pattern properly. Put it in. I mean, it was literally like a 30-minute fix. I felt bad doing that, but 30-minute fix. The hardest part was these were such critical apps. The hardest part was, okay, now we got to test everything. Now we got to make sure everything's right. That was a little too easy. Same thing. It does not top over 500 megs to this day. So that was 2 right there. Now, out of the gate, the third one, this was a preemptive one. This was an app that we actually run right now, and the code base had not been touched since 2014, but it was one of the other offenders on the list. So what we were doing in this case was we was actually doing current work. We were opening a hoe up basically on the outside function to allow another app to make calls to it to use some functionality that the service already provided. Didn't want to reinvent the wheel. But as I was going in to check the code, I said, you know what? Let's just see if we can stress test it before I'd even do a code review, check it in, anything like that. And I know that's going to be terrible to see. So basically our console app's same app I got up on GitHub. We just added a little extra where we can call some extra functions. Here's your 2 output memories. They're both the same. One is an internal one running inside the service. You can notice the size on it's a little high. This is the external service that we're testing. It's currently jitted up at 45 megs. Start to test off, get my baseline. Here I've hit it I think I hit it with 20, yeah, 20 users. Immediately, if you notice, the one behind the scenes actually jumps up in memory. I wasn't expecting that. This is the one that I'm actually trying to test. It jumps up in memory and it shows me that I've got allocations going. But I'm really eyeballing the one behind because that's where all my business logic really lies. And I really thought the problem was in the other service. And by the way, these ain't staged screenshots. These are me taking them as I'm doing this for the first time. So I hit it with 20 more users. There's my problem. I'm starting to see I'm not deallocating anything. Everything is rising. It's one behind the scene. Both of them are still climbing. I'm climbing up. The garbage collector actually is not even firing at all. I'm just growing in memory. It's just the one. No. This time I think I hit it with 40 users, and again, memories grow. Nothing's coming down. Everything's deallocating. And then finally, this is the one where I hit. What did I hit it with? I think I hit it with 40. Yeah, 40 again. At this point, both of them is growed. Everything's growed. It's topped out. I actually got the message on my system, I'm out of socket connections. My box has no more TCP ports to give, no more connections. And I'm thinking, you gotta be kidding me. This app has not been touched since 2014. It's been running out there. I'm actually blown away because I was thinking that there's something in this other service when the other service turns out to be perfectly fine. What comes about, well, I'll just bring up the screen. I bring up a graph. I start looking. I don't know if you guys can read that or not, but can you see something popping up on the top up there? Maybe something standing out a little bit.
Service channel.
Service channels. Okay, now I'm starting to click. Okay, I got socket connections, no more resources. My service channels are up on the top. And then when I sort it by the counts or the other inclusive size, it actually tells me what the actual service client I'm actually using, one of my references. That's one of our internal references. Now I know exactly where in code I need to go look at where this problem lies. I literally went there and looking at it, I'm like, okay, it looks like we're doing everything right. And then I realized we're not closing the connection. Simple little 5-minute fix, not hard at all. Put the fix in, turned right back around, and I said, all right, let's hit it again. Immediately, I see a difference. And notice the sizes this time. I'm staying around the 100 mark, 150 mark. Everything's looking good. Let's see where, hit it up again. I can't see, that's 20 users. Notice my memory is actually a lot smaller this time on the background service. Both services are staying steady. I'm freeing up memory. Everything looks good. I continue to hit it. This time I go for the gold. I hit it with all 64 users. And I don't take any more screenshots after this, but I fill the panel up. I go for a while. And memory never gets above 150 megs on the background one. Everything continues to free up great. Problem solved. Actually, this was a preemptive. It's actually out in production, but we hadn't turned on the faucet yet to the extra users. So this was a preemptive fix. And doing something like this, replicating this on your local box, it might save you a lot of time and trouble just to preemptively hit it, just to see. But if you don't preemptively try it, at least keep this knowledge in the back of your head, because if you ever run into that production issue, it's maybe a great thing to pull up just to try behind the scenes. So I think I may have went over time, but is there any questions? I know that was a lot of information in a short time. I'm sorry I tried to squeeze in.
Awesome presentation, first of all.
Thank you.
Really good. I run into this kind of thing with other technology platforms, and I feel the pain.
Oh yeah, it's a scary situation.
It can be very frustrating.
Yes.
You mentioned these tools. They first appeared in 2013 and 2015.
Yes.
Were there third-party tools like this available prior to that? Because I'm surprised These
I'm
haven't
really surprised there hasn't, I think, Stephen, you may have found one.
Yeah, so JetBrains has a tool out there called, it's like dot profiler or dot memory, something like that.
Okay.
It's pretty
Yeah.
great.
I just
Red
don't
Hand's
have
profile,
the
that's the
Apple
one.
stuff from
Yeah,
the-
I know.
Redgate. Yeah.
Do you know, is this available in all editions of Visual Studio, or is it required?
To my knowledge, it is.
Okay.
To my knowledge, it is. I'll find out for sure though, and I can put something up there to find
The
out.
last thing, I don't know if you guys do any mobile stuff with Xamarin. Do you know if this tool supports
As-
Android apps and iOS apps when you're developing them with Xamarin?
As far as I know, as long as you can run it in .NET inside the studio, it'll work. Now, one thing we have found out.
I'll let you know tomorrow.
Okay, let me know, because that's a
This is
good.
very timely for me, so
Oh,
I'll
yeah.
give it a try tomorrow. I'll let you
Right.
know.
One thing we did find out is, I don't know if anybody ever remotely connects or remote debugs to another server. It won't let you do it. It won't see it there. It'll tell you, it'll give you an error box on that. I
But I
did
believe that is coming in VS15.
VS15. Okay, yeah.
Yeah, you have to, for iOS development, Apple's licensing requires you to build the app on the Mac and run and debug it on the Mac. So you have to connect to it remotely over a network. Even if you're running on the Mac, you're still doing it virtually from your Parallels desktop installation to the
Right.
Mac OS side. So
That may bite you
it won't work with
there.
that. But it could work with Android because that does run within the Windows.
Now, I have been able to attach the process locally, so you can attach the process if you don't want to run it just out of IS Express, out of the solution. But once they add that, I mean, I think I want to hammer Microsoft on this because I got some actual additions I'm going to put in as my wish list. But even when they add that remote, that's going to be awesome. That's going to be the icing on the cake.
Yeah, the performance tooling is in community, professional, and enterprise. The community is the free version. So.
Awesome.
Yeah.
Thank you.
But like I said, all the source code for that, even that little console app, if you want to take a look at it, it's up on GitHub. And if I add any more additions to it, then I'll put it up there along with any notes. If anybody else has any questions.
What was the actual fix that you put in? You said it was simple. Was it a try-catch statement and closing connections, or what did you actually do?
So the one was an AutoFact issue. The AutoFact wasn't wired up properly. I don't know if anybody uses AutoFact. That's like a dependency injection service location pattern. With WCF services, you have to wire it up a certain way to work with a WCF service. Another thing we found out, if you use workflow services, can't do it. Workflow services actually has a built-in service location pattern into it that you can use out of the box. Microsoft doesn't promote that a lot. We actually had to dig for that one. The other fix was the iDisposable pattern. One of the classes had a bunch of references to other class objects. It just wasn't cleaning up everything behind itself. Put an iDisposable on it, cleaned up the references, fixed. Literally a 10-minute fix. The last one was literally basically a try-catch, putting a finally up on it to clean up open the connection. It even had fault protection around it to abort the channel. It had everything there. It just didn't properly close the channel. Simple fix. But it had been out there since 2014. So these things can be out there right now. You know, it's just playing with it. Just you never know when it may bring to the surface.
Which the AutoFact one that Brandon mentioned was a particularly bad one because the default configuration has the problem. So you'll add it to your WCF service, everything will work great, and then this will sneak up on you after you get into production.
Yeah.
So I don't know if you remember the specifics of it, if people want to, if you can maybe.
So when you wire it up, one of the easiest ways to do is you can go behind, I may can bring that up real quick. You can go behind the service. To the actual service declaration. I'll view the markup here. Basically right here, this factory declaration here, you can actually see I've actually wired this demo up. So you can actually download the demo and see how it's wired up. You actually take on the AutoFact host factory, it's built in. You wire it up there that way, and then you can anywhere where you want, however you want to do your app startup code, basically your one-time initialization. They actually have a link on this. I can post a link in the notes after the meeting because they have a whole tutorial on this. But you basically register it up here. What you want to do is you take that service location, this host factory right here. It's a static class, and you already wired it up in your markup. You set the container equal to the container that you're creating. It does everything for you behind the scene. Again, a little simple wire, just how you wire it up. But normally it comes out of the box. It's meant to be used like in a regular Windows UI service or something like that. It's going to be closed. It's not really meant to be wired up in a service. It's going to be long-lived with many different containers going on behind the scenes. So easy fix there. And like I said, if anybody deals with workflow foundation services, I can give you, I can put some notes in there too on how to use a service locator. It's built in out of the box. So that's about it.
Did you at all look at using the using statement in C#?
Yes, so you can use the using statement. I'm sort of an old school. I still do the try-catch finallys. As long as you're keeping all your values, variables, and things right there together, and you're done with them, you're not going to carry them outside of the using. Using's perfect. You can go with that.
So using automatically looks for disposable classes and disposes of them at the end of the closing statement, right?
Yes,
yeah.
Absolutely.
Cool.
I was just reading that, and when it compiles down, if you decompile it, it actually does the try-catch family.
Yeah, I still like to do the old manual way. So behind the scenes, that's what it's doing. So yeah, you can use the using, absolutely. Anything else?
Awesome. Thanks, Brandon. All right, so it's swag time. So we started this last time. We got t-shirts, cookbooks, randomness in here. Yeah, so on your, anybody who wants one, I've got some Teller stickers and pins. You can have that too. But on your, does everybody have a number on their name tag? If you don't have a number, speak up. I'm all right. All right. So we'll do about 15 of these. So if I call your number, you can come up and get something out of the swag box. Number 6. There you go. Number 11. Gosh. Number 26. Yeah, so the little red bag is a pair of earbuds from Microsoft, actually. So thank you, Microsoft. Number 18.
Kill if he calls him a 3.
There we go. Number 16. 16. Number 21. It's like bingo or something. Number 11. 12. It's not unique random numbers. Yep. No. Number 10. That's Chris out here. Alright, Tommy, better hurry. Number, no, you do that one again. Number 8. Number 12. Number 9. Nice. 16.
Oh, you already got some.
All right, let's do that one. 17. All right, 2 more. Number 10. 10 and number 4. We're about to leave. Thank you very much for coming out tonight. We really appreciate you supporting the group. Just want to stress real quick, 2 weeks, we've got the .NET Conf local event. We're going to have food at that. It's a daytime event. If you can kind of wrangle some of your coworkers in to come into that, it should be really good. We're kind of planning how we're going to present that. It should be really, really cool. I'm excited about that.
Tell me, it's in the first floor of this building?
First floor, yep, bottom floor of this building, really just right below this, first floor. Should be a good event. We have room for up to 80 to 100, so we got plenty of room. Bring as many people as you can. Really want to show Microsoft that we've got an active .NET community. So look for that. It's out on the Meetup site. You can find it there. If you have any trouble, just email me and let us know. Otherwise, appreciate you coming and hope you can make it next month. Thank you.